Everything around you, from the air you breathe to the stars above, is made of tiny building blocks called atoms. But discovering them took over 2,000 years. For thousands of years, people wondered what matter was really made of. Without modern science, they searched for answers using only observation and logic. If you keep breaking something into smaller pieces, will you eventually reach the smallest possible piece? That simple question became the beginning of atomic theory. Around 400 BCE, the Greek philosopher Democritus proposed that everything is made of tiny invisible particles. It was a remarkable idea, far ahead of its time. He called these particles atomos, meaning uncuttable. Although he had no proof, the concept was surprisingly close to modern science. Without experiments or evidence, most scholars rejected the idea of atoms. For centuries, it remained only a philosophical theory. As time passed, the atomic idea was largely forgotten. Other explanations for matter became far more widely accepted. Everything changed with the rise of modern chemistry. Scientists began testing ideas through careful experiments instead of relying on philosophy alone. In the early 1800s, John Dalton revived the atomic theory. His studies showed that elements combine in fixed proportions, providing strong evidence for atoms. Dalton's discoveries transformed atoms from an ancient idea into a scientific theory. It became the foundation of modern chemistry. Dalton proposed that every element is made of its own unique type of atom. His theory laid the groundwork for modern chemistry. As more elements were discovered, scientists noticed repeating patterns in their behavior. These patterns hinted at an underlying order in nature. In 1869, Dmitri Mendeleev organized the elements into the first successful periodic table. He even predicted elements that had not yet been discovered. The periodic table revealed that the elements follow consistent patterns. It became one of the most powerful tools in all of science. Scientists once believed atoms were indivisible, but new experiments soon revealed that atoms had an internal structure. In 1897, J.J. Thomson discovered the electron through cathode ray experiments. It was the first evidence that atoms contain smaller particles. The discovery of the electron completely changed how scientists viewed the atom. It was no longer the smallest possible unit of matter. Ernest Rutherford tested atomic structure by firing tiny particles at an incredibly thin sheet of gold. The results shocked the scientific world. Most particles passed straight through, but a few bounced back. Rutherford realized that atoms are mostly empty space. He concluded that nearly all of an atom's mass is concentrated in a tiny central nucleus. This discovery reshaped atomic science forever. Scientists later identified positively charged particles called protons inside the nucleus. The number of protons determines which element an atom is. Another discovery followed: the neutron. Although it has no electric charge, it helps keep the nucleus stable. To explain atomic structure, scientists imagined electrons orbiting the nucleus like planets around the sun. It was a useful model, but it wasn't the full story. As experiments improved, this planetary model began to break down. It couldn't explain how atoms remained stable or behaved during certain experiments. The answer came from quantum mechanics. It revealed that the atomic world follows rules unlike anything we experience in everyday life. Electrons don't travel in fixed paths around the nucleus. Instead, they exist in probability clouds where their exact location cannot be predicted. At the quantum level, particles can behave like both waves and particles. As strange as it sounds, countless experiments have confirmed it. Scientists continued looking deeper inside matter. They eventually discovered that protons and neutrons are made of even smaller particles. Those particles are called quarks. They are held together by the incredibly powerful, strong nuclear force. Today, the Standard Model explains the fundamental particles and forces that make up the universe. It remains one of the most successful theories in modern physics. Scientists now believe that a small number of fundamental particles make up everything in the universe. Every object is built from the same basic ingredients. The atoms in your body are the same as those found in stars, planets, and distant galaxies. We are all connected by the same building blocks of matter. Many of your atoms were forged inside ancient stars billions of years ago. When those stars exploded, they scattered the elements that eventually became part of you. Understanding atoms transformed civilization. It made modern chemistry, medicine, electronics, and nuclear energy possible. Every computer and smartphone works by controlling the movement of electrons through tiny semiconductor chips. Atomic science powers the digital world. Modern medicine also relies on atomic science. Technologies like MRI scans, PET scans, and radiation therapy all depend on understanding how atoms behave. Scientists are still exploring the smallest parts of reality using powerful particle accelerators. Each new discovery brings us closer to understanding the universe. So far, quarks appear to be fundamental particles, but researchers continue searching for an even deeper layer beneath them. From tiny insects to massive galaxies, everything is built from the same fundamental particles. The entire universe follows the same physical laws. The search for the building blocks of reality is one of humanity's greatest achievements, and the journey isn't over yet. Follow Fact Vault for more incredible science and discoveries.